Alright, hello again. So in the last video, I promised that we're going to create a Pixie server out of a Raspberry Pi, right? So in that video, just to recap, right, we created a Pixie server by combining an Edge Router X, which served as the Dhcp server, and a Synology NAS, which served as the TFTP and HTTP server. And now we're going to combine that into a single machine, a Raspberry Pi, and of course we're going to automate the whole thing. Alright, let's get going. Alright, so this is how it's going to work. We have our home network again, right? And in this home network, my workstation is currently connected to it. And then I also have a Pixie Pi, a Raspberry Pi, Model 3B revision 1.2 that's connected to the Wi-Fi and also connected to the lab network, right? And then the lab network has a gateway over here allowing machines such as these MAAS 01 and MAAS 02 to go out into the outside world and connect to the internet, right? And so our MAAS machines over here would be managing any virtual machines or any bare metal machines that would be connected to this network, right, to the lab network. But in order for us to get MAAS set up in this lab network, we have to install Ubuntu in these Intel NUCs, right? Now, I don't want to do that. I don't want to do that manually, so I'd like to automate that. And so that's where Pixie Pi comes in. So Pixie Pi will contain a Dhcp, TFTP, and HTTP server all in one. And it will serve out as the temporary Pixie server for MAAS 01 and MAAS 02. And of course, Pixie Pi needs to be configured, right? Because I just mentioned it has a Dhcp service, a TFTP service, and an HTTP service, right? And of course, I don't want to manually do that. And so in my workstation, I have a Pi Infra application where I can just execute it, giving it all the information that it needs, and then it'll configure the Pixie Pi. And then once the Pixie Pi is up and running, then I can turn on MAAS 01 and MAAS 02, and then they will go and auto-install based on the instructions from our Pixie Pi, right? And then once that's done, and I'm not going to cover this in this video, but once this is all done, once MAAS 01 and MAAS 02 are set up, then I'm going to disable Pixie Pi, or at least the Dhcp service in Pixie Pi, so that MAAS can take over this lab network. Alright? Cool. So let us get started. Over here I have, this is my project, my Pi Infra project, where I have my inventory, the Pixie server, that's the address of our Pixie Pi right there, .21 in the Wi-Fi network, as you can see over here, right? And then for our group data, we're going to feed it a number of things. First of all, the Pixie server address in the lab network is going to be 100.2. Again, over here, 100.2, right? And then we're going to tell it a number of things, like here's the configuration for our TFTP, configuration for our HTTP, and the boot files that we're going to make available to our operating systems, right? And so on and so forth. I don't want to get into too much details on this one. Perhaps we can cover this at a later time. But the thing that that's very important over here is, first of all, if we were to define the machines in our Pixie server right now, right, we'd have a couple of problems. First of all, the Ethernet problem. We don't know. Let's just say that these two NUCs here are brand new, and I don't know how Ubuntu is going to recognize the interfaces over here. It could be ENS33, it could be EN01, and so on, right? So we can't define our machine here yet, right? And the same thing with storage. I don't know where what the path of the disks will look like from Ubuntu. So what I'm going to do instead of hard coding this or setting it up right now and just do a trial and error, we're going to comment this out and just say Pixie data is this, right? It references the TFTP configuration, HTTP configuration, and then the open source or the operating system image source URL, right? It'll specify the boot files, and then we're just going to give it an empty list of machines for now. Okay? And then we are then going to run enable Pixie, right, which will configure DNS mask, which serves as our combined Dhcp and TFTP server. And then Apache 2 is going to be our HTTP server. And then finally we're going to use this this Pixie deploy module, or in PyInfra parlance, package deploy, right, to configure the entire thing. Alright, now before we do that, let's look at our PyPixie. This is our PyPixie, and if we are to look at CPU info, we can see that it is in fact a Raspberry Pi 3 Model B revision 1.2. Cool. Now, what are we going to do here? So let's see. Cuddle, status, Apache 2. It's not yet configured. System cuddle, status, DNS mask. It is inactive, right? I could go ahead and uninstall this, but let's just leave it there. I had it installed in a previous run, but all this, it's not going to make any difference anyway. Alright, so let us run this thing. So PyInfra, we're going to say PyInfra examples terminus pi, that's the name over here of this project. And we're going to serve it, we're going to give it our inventory, our Pixie server inventory, which contains just one IP address, and that is the Wi-Fi IP of our Pixie Pi. And then we're going to run the enable Pixie set of operations. Alright? Okay, let's get started. That says, oops, I meant father. Alright, great. So let's go back to our Pixie Pi. Right, and then we are going to check the status of DNS mask. It's running, nice. We're also going to check the status of our Apache 2. It's also running, very nice. Alright, so here is the thing that we're going to do here. Alright, first of all, we're going to tail the logs of DNS mask over here. Alright, so it says no address range for wireless LAN 0. That's fine because we don't want to serve Dhcp on that one anyway. We just want to serve Dhcp in our lab network, right? Now, we could also do a Tcp dump over here. Where is that? Okay, so let's do Tcp dump, or rather sudo Tcp dump and then don't resolve the host names, and then we are going to limit it to ETH0 and then port 69, because that's no port 66 or port 67. That's going to be our DHCP stuff, right? Now in this pane we're going to try and simulate a DHCP discover in ETH0. So I'm just going to paste this. It's a handy script, by the way. So we're going to do that, and as you can see, we get a request in our ETH0, right? And it also gets a response. It says the next server IP is going to be .02. That's where you're going to get your Pixie stuff. It's not saying what boot file it is, and that's because this client architecture that the script is providing does not fall within the client architecture values that we provided in our data over here. Like if we look at our boot files, we only said this boot file will only apply to client architecture 7, right? And so if we look at etc DNS mask conf, at the bottom over here it says to only provide this for client architecture 7, right? That one didn't provide. This nmap script doesn't provide, and it doesn't have any option for you to provide it. But once we boot up the NUC, then we should see some information over there, right? Great. All right, so over on the right side is the TCP dump for our Dhcp. Now we also need TCP dump for TFTP, right? So let's do that here. Sudo TCP dump vvnn interface eth0, and this time port 69, right? Because that's where TFTP listens. All right, so nothing's going to happen here right now because I haven't started the NUC yet. So let's do that. I'm going to start recording it as well. All right, so we're recording now. We're going to turn on the NUC. All right, and in a few seconds it should show the boot menu. All right, press F12 to network boot. Of course, got to hit it multiple times. You know, that's just how it goes, right? All right, so it says Pixie booting, and as you can see, Dhcp is working. There is also some action going on in the TFTP server. There's some error files over there, but that's not a problem because the Pixie client is just going to go through a number of files until it finds one of those files, right? In this case, it found grub.config, right? And right now, since again we didn't define any machines here, we only have one item, which is custom install Ubuntu, right? And that's what we want, because in this custom install, this is where we are going to get the Ethernet and storage information that we need to put into our group data file, right? Okay, so let's wait for this to boot up and get to the Ubuntu installation UI. All right, we're getting a number of things from the TFTP TCP dump as well. We can see that it downloaded VM Linus and initRD, right? And then it keeps requesting for Dhcp every time it boots up. All right, and now it's downloading the ISO. Oh, I forgot to tail the logs for Apache, but if we had been tailing the logs for Apache, then we would also see you know, some logs over there saying this dude over here is downloading the ISO. But that's fine. This is proof enough. Alright, so we are now in the installer interface. Right. So what I'm going to do here is I'm just going to click through a number of things to get the information that I need. First of all, that information, right? So as you can see, it says over there, the name of the interface is going to be EN01. All right, so we'll just leave that be, right? And just remember EN01, and now we're gonna just leave that interface, click continue over here, and get to this part, right? So we have that information, but that's not the information that we need. So let's click on done and get to this part over here. Right? This is the part where I can get information about the disk. So the disk is going to be in the path dev/dev/sda, right? And that's all the information that I need. Now I can go back to my group data, and then I am going to configure the machines based on that information. All right, so I'm going to stop this video now. All right, so back here in our group data, right? Remember, I did not define the machines yet because I didn't know what information to put in the machine or in the machine section. So I am going to uncomment this now, but I'm going to comment out machine 1 because right now the machine that I have running over here is going to be machine number 2, right? So this is going to be MAAS2 storage config. We'll get to that in a bit. And again, this one, it says it's set in interface ENO1. So we're going to say ENO1 over here. And we're going to give it an address of that. Name server is going to be the same as what we configured in the Dhcp data. And then same thing with the router, right? And now for the storage config. Right? For the storage config, I am going to uncomment this one. Right? This storage config is the stuff that we're going to work on. So if I look at our volume over here, we have path is dev SDA, as we saw over here in the installer, right? And we are going to give it a boot EFI of 512 MB, and then a /boot of 1 GB. And then we also have a partition that we're going to use for volume group. For this one, the volume group is actually quite large. We could go as high as 200 gig, right? So 200 gig for right now. This information only accepts bytes, right? So I'm going to say 200. That's kilobytes. That's megabytes, and that is gigabytes, right? So I'm just going to place that here. So this is going to be 200 gig for our partition, which will house our volume group right here, right? So we explicitly gave this an ID of partition for Ubuntu VG so that we can list it under the devices section of our Ubuntu VG volume group, right? And then we are going to use up some of that data over here. Now, no, don't just copy and paste this size and put it here, because that's going to cause a problem later on. Mainly because it's not going to be a full 200 gigabytes that's free, because of course you're going to need some of that space for the volume group metadata. So let's just say we're going to use 150, right? So 150 gig times 1024, that's kilobytes, and then that's megabytes, and that's gigabytes, right? Oops. Alright, so this is 150 gig, right? Alright. Let me zoom that out. Alright, so just a review, for our storage config, we defined that the disk in dev SDA is going to be partitioned 3 ways, right? One is going to be for the boot EFI, right? And the other one is going to be for the boot directory. And then the other one is going to be just a partition that we're going to use down here in our volume group. That's one of the devices, the only device that's being used. But of course, you know, if we had more disks, we could also list it down over here. But anyway, so that's our volume group, and then our volume group has only one single logical volume, size 150 gig, and we are going to mount it in the root directory. Great. All right. So now we have configured our machine information. Now what's going to happen next is we are going to rerun PyInfra, which will reconfigure the Pixie server, and then we are going to go back and reboot this, and then we'll see another menu item in the grub interface, right? Okay, let's do that right now. Enable Pixie. Okay, great. So now we have our Pixie server reconfigured. If we look back and just create another window over here, what are we going to look for? Oh yeah, so Sego, HTTP, we have MAAS02 over here. That's our user data, I forgot. We are looking for TFTP boot there. Alright, TFTP boot, we have our grub directory. Alright, and over here, we can see that our PyInfra application added an auto install now for MAAS 02, right? And that should show up when we reboot this machine. Okay. Alright, so I am going to start another recording. Okay, so we're still back in this machine, but now I'm going to reboot it, which is... Does that work? Control delete? Yes, okay. We'll reboot this, and then again we are going to do a network boot. Alright, it's network booting right now. And as you can see, we have two items now. Auto install Ubuntu for MAAS 2. That's what we want, right? Let's go back to very quickly. Alright, there. Okay, so we should see some action right there. I think we just saw the TFTP stuff going on right there. It's downloaded the kernel and the RAM disk image again, like right, VM- and init-rd. Alright, it's doing another Dhcp request. There's a request and reply over there. Alright. Okay. It's now it will go ahead and re-download the ISO. But after it's done downloading the ISO, it should not stop at the installer interface. It should go directly to Ubiquiti, and Ubiquiti will configure the machine, and then it'll reboot, and then we have a working machine up and running, right? Yeah, 1 second. Let's also tail the HTTP. We're done with this, so let's tail var log Apache log. Alright, so yeah, nothing going on yet, right? So this thing is still trying to do some hosted network lookups for whatever reason. And this one I don't fully understand why it's spending so much time over there, but it eventually gets through that. Alright, here we go. So it's getting the metadata and user data, and then it's continuing on its merry way. Alright, let's see. Alright, Ubiquiti is now starting up, it's configuring stuff. Removing previous storage devices. Okay, so it's configuring the storage device now. Alright, partition, everything's good. File systems are good. It is formatting the logical volume. Nice! And it all mounted. Excellent. This is cool, huh? Man, I'm totally nerding out. Alright, installing kernel. I think the next part over here is going to be, it's going to download the security updates just before it reboots, and then we should be able to SSH to it in a bit. Note, by the way, that the SSH keys that I put in the user data is hard-coded at the moment to my SSH public keys. I don't recommend using this for using my scripts or using my application for public interface right now, so I might have access to it. But yeah, just so you know. Then again, this one is alpha, so you shouldn't be using this for production stuff. why is it when, why does this always happen when, you know, it's always during the time when you're doing a demo when shit that just start breaking or slowing down, like the internet. Now it's sped up. Crazy. Alright, so it's done installing. Alright, it's going to go back to the boot screen, but I'm not going to press F12 this time, so that it's going to just boot up normally. And we also should not see any Dhcp request, because this one now is fully installed and it is its network is statically configured. Alright, there we go. And it says MAAS login right there. Sweet. Okay, I'm going to stop this video and then go back to my screen. Alright. Yes. Nice. Alright, so let's see, net plan, start config. Alright, so ENO1 is statically configured, so it's not going to do any DHCP requests. That means that we can go back to our PyInfra project over here and just say disable Pixie, and even if the DHCP service in our Pixie Pi is disabled, right, our machine MAAS02 is still gonna boot up just fine because it's statically configured now, and that's what we want, because we want MAAS to serve as the Pixie server now, the DHCP, TFTP, and HTTP server. Right? Excellent. So going back over here, and if we try, and where did we make that fake request? Nmap, right there. Right? It's gonna say nobody's responding, man. Right? Cool. That's just going to fail a bit. Alright. Now, with the DHCP server gone, let's see if this thing still works, right? So I'm going to record this. Alright, here we go. I'm going to press Control Alt Delete to reboot. And even with that, it's still going to be just fine. Even with the DHCP server gone. Good. Alright, stop this video. And go back over here to the second window of my Tmux, and then see if I can still SSH to that. Yes, I can. Excellent. Alright, so a recap of what we just did. So I had my workstation running PyInfra, automatically configure Pixie Pi over here to be the temporary Pixie server, and then we had MAAS02 boot up and Pixie boot against Pixie Pi, and then it got automatically configured, and then we disabled DHCP, well, the whole Pixie stuff over here. So now MAAS can, MAAS02 can boot and reboot as much as it wants, and it can start MAAS and then be the Pixie server in this lab network, and our Pixie Pi will now just be a jump box for my workstation. Alright, so that's it. I hope you found that informative. I certainly learned a lot of new things in this one. Also had a lot of fun. Good luck in your own adventure. I hope you find success when you try to perform this in your own network as well. Alright, have a good one.